Hi, I'm Tom and I talk about code. Welcome to another compiler live stream where today we're going to be doing register optimization. We're going to be putting variables in places and referring to them to avoid a lot of redundant work on the stack. This is a compiler for a language that I'm building in Rust that runs on a virtual machine that I'm building also myself in Rust. In the previous few streams, we did a few things. We optimized chains of binary operations. So if we have, for example, A plus B plus C, it means we don't have to push all of these things to the stack as we go. We can kind of, we'll pick, say, register A, and we'll put B plus C into A, and then we can just add on to A as well, and we'll get the result. So we've got a system of kind of utilizing registers in a slightly smarter way. So this is done and kind of works. And also, the other thing that was kind of interesting, this behavior that I didn't really plan when I wrote my machine, if I have a function foo that returns an integer, it returns 5. This returns, every function returns in the A register. So what this does is puts the number 5 in the A register, right? Except what it actually does in the old world is push the number 5 to the stack, then pop it to the A register. And then if you have a function like your main function, this function returns whatever was, the result of evaluating foo. This function will call foo, push whatever's in the A register to the stack, and then pop it off of the stack back into the A register. So it does all this redundant work that was a bit silly. So I've also written code that avoids doing this. And I wrote a test to see if this works, and I found that it kind of didn't, right? So I wrote this example. We could see the chain of binary operations worked. So I compile this, I cargo run my language compiler, I pipe this out into BaseEnc, because I need to encode it as base64 to run it. I've got a little web UI. I need to remind myself how BaseEnc works. It's just 2 hashes, two dashes. So let's go cargo run bin lang BaseEnc base64 URL. It needs to be URL encoded because they're using it in the web. And then I'm going to copy this. Would be good to have a nice little helper for that. So then we can load this into my web front end and run it, and something goes wrong. Something goes wrong here. Is it just normal base64? Shouldn't be. It should be URL encoded, right? Yeah. Okay, well that didn't work. That's fun. Am I printing out extra garbage? Oh, I forgot to give it a file to compile. That's really funny. There you go. There you go. Test2.code. Beautiful, beautiful. I don't think I've left this in a broken state. Yeah, cool. So we can load a binary, and we can see that in this binary, it took me a minute, but we got there in the end. In this binary, we do this chain of operations. We put things in registers, we add on, and then we do this return stuff. And my goal was that we wouldn't have to push and then like if we step through this, right? If we tick through this, let's get rid of. We can see we come through. What's the operation we're doing here? We're doing x equals 3 plus 7 plus 2 plus 5. So we're gonna see the 5 and the 2. We add them together, we get 7. We load the 7. We add them together, we get 14. We add the 3, we get 17, and then we pop the stack into C. There's just something a bit, and this is to do with, I don't know. So basically, I don't think we're quite keeping track of this properly. Anyway, Uncle SCN, welcome. Welcome, thank you very much for the follow. Great to see you on board. Basically, the thing I worked out was, I wasn't handling variable assignment, right? I haven't done anything for variable assignment yet. So actually, if we just don't assign to a variable, I think, hopefully, it's going to work a little better. There's like this extra step that it just doesn't consider. And here, yeah, it no longer does this weird pop that doesn't make any sense. We end up with the value in the A register, which is cool. And then when we return, it's just going to be, the number 17 is going to be in the A register, which is what we want. So we do all this, we jump back to the end of our program, and we're trying to return return the number 17 in the A register. That looks like what we've got. So basically what I did last stream worked. I was just a bit silly in my test program. But it would be nice if we could do this and not do something silly with it. So we've got to think about that a bit. We've got to think about that. So if we look at what we were doing last time, codegen block, this return statement, sorry, has an expression. We now, when we compile an expression, we get a result of compiling that expression. Instead of just having the assertion that any expression is going to push its result to the stack, we now get a result that tells us what the destination of that expression was. If it went in a register, and that isn't the A register, then we need to move it into the A register. Otherwise, if it's on the stack, we need to put it into the A register. Now, there's something else we have to do here, right? Something else very important we have to do here, and that is, when we override what's in the A register, we need to actually update our state to say, hey, whatever was in this A register, it's no longer valid. But also, I don't know if we preserve that over function boundaries, so it might not matter at all. Let's circle back to that. Let's assume that returning from a function invalidates our entire register state. We're just not going to track it anymore. I think that makes the most sense right now. This we also need to think about, right? So here, I didn't think about this. If we have a statement that's just an expression, just a 0, we pop, oh, this is even better. This is even better. Let's take a detour and do this first, because I think this is good, right? We're going to have to go through all these statements and evaluate how they handle these expressions, but this is a really obvious one, right? So what does a freestanding expression? So for example, let's look at a freestanding expression. Hi, Bobius, by the way. Hello, welcome. Sorry, I was deep in a thought in my brain there. Welcome. So what does that case look like, right? The case where you have a freestanding expression. For example, if we just have a statement that is x, right? Or I guess the more obvious example would be if we just call a function and do nothing with the result, we forget about it. In the old world where every compiled expression just went on the stack, that meant we popped the stack into the 0 register, we threw the value away. Now, sometimes the result's going to be in a register. So if the result's in a register, it's going to be very similar to the block up here. If well, first off, we also need the result. It's not mutable anymore because we're going to out extend the result instructions. So if it was on the stack, if the result was on the stack, and then we don't need a let for this, we just need an if res.destination. So if it pushed something to the stack, wipe it out because we just don't care. It's a no-op. Strack. Thank you, Bobius. This is why I don't need an LSP. I've got chat LSP. Okay, awesome. So that's cool. That's gonna save us a little bit of work. What other expressions are important here? Assign struct field. So this is variable assignment in general, I think. I think I rolled a variable assignment into a special case of doing struct fields where it's like x.y.z equals something. I think, just having x equals something is now a special case of that, which is cool. So the expression part of that, well, we just need to care about what the result is. So that's going to be kind of similar. What else do we have? We have assign deref. This one's going to be really important too, because we have a left-hand side and a right-hand side. I don't really know what that means. We push. We pop. So actually this one's fine because this is another case of a statement where we have two things on the stack. When we assume those things are on the stack, we just pop them into registers to keep going. And that's actually really easy to deal with because now we just need to conditionally either do this or just accept that it's already in a register, in which case there's no work to do. So that's good. That's good news. That's very good news. Assign array. This is another thing where we do need at least 2 registers though. So that's kind of important, right? We need, and I had this problem with binary expression chains as well, binary operator chains as well, where we need 2 temporary registers, but I don't really have 2 temporary registers. So we need to think about how we get a second temporary register. How do we ensure we always have one? There's something we need to do to the state, right? Like if we're here, we need to say, hey, state dot or let new state we need to be able to do something like this, right? We need to be able to get a new state that we know is going to need two temporary things. This is a good point. This is a good point. A statement assign. This is a good point. It's now just assign, really. Assign something in general. Arrays are special though. Arrays are still special. Oh no, hold on. Maybe it's only in the parser that it's a special case. It looks like we still do have usual assign. I thought I did this refactor. Maybe this is in a branch somewhere. Declaration and assignment are very similar. And then there's declaration with an expression. There's going to be a lot of duplication here. This is what's making me nervous right now. This is the only thing I'm not... I don't know how I'm going to do if statements necessarily. Because... Well, if statements are okay, I guess, because we're going to do it once. But the while loop is going to be messy because we have to do it a bunch of times. This is a lot to unpick. So what were my goals for the stream again? I had a very simple variable assignment. So we're just going to do assignment. And the one extra bit I did for freestanding function calls. So that means we need to do declaration as well. So we've got a little checklist here. So declaration, we're going to have to change. Declare without an expression, that's fine, we don't need to do any work. Assignment with an expression, definitely. And now locals have the potential of living in a register. Arguments, I guess, could be in a register as well. But globals, I don't think we ever put in a register. We never kind of track it into that level of detail, so that'll be okay. But then we have this assumption that the compiled expression puts something on the stack, which we're obviously going to have to deal with. My light just did a little flicker. My light might imminently die. Okay, so stack, we pop into C. So this is good. This is good. Anything where we assume something went onto the stack and then the first thing we do afterwards is we pop, that's really easy to transfer. That's really, really easy to transfer. This one is going to be... This just turns into an assign deref. Assign deref is going to be a simple one to tackle first. Struct field is going to be annoying. Let's start with assign deref. No, this has the same problem as binary operation chains. There's so many little... Death by 1,000 cuts here. Death by 1,000 cuts. So let's start with assign. Let's just do the basic assign. That's probably going to tell me the most things that I'm missing to do this. So we get whatever the identifier is from the scope. If it's a local, we need to try and find that local in a register. Like if that local is already in a register, we don't have to do any work. So let's look at CodeGen expression. This shouldn't be in CodeGen expression, but here we are for now. Register state. So the expression state, get variable register. So if there is a variable with this name in a register, that will be good. We need to be careful with scopes. Like when we call a function, we're going to have to wipe out any locals because two different functions could have a local with the same name, and because we do this by name, that's a bit of a problem. So let's grab if let sum register is state dot get variable register. Mr. Ed Makes, welcome to the stream. Thank you for stopping by. Are you a programmer? Are you a Rust person? What has drawn you into this compiler optimization madness? So, if we have this variable in a register, we still need to compile the expression because we're assigning to it. Actually, I think the thing that we really probably need to say here... I guess the thing we could say here is wipe out whatever value is currently in here. But what if it's on the right-hand side? So The thing I've instantly gotten stuck on here is the case where we say, you're a programmer with a strong interest in compilers and VMs, you don't know Rust. Nice. I also didn't know Rust until I started doing this. And there's a lot of stuff I don't know about Rust. So if we say x equals foo x, right? It would be nice to actually tell this expression that it should just reuse the same address for x, as long as it can. And I think I can probably engineer an example in my mind where that's not really appropriate. But it should be okay, right? So at the very least, after we've run this expression, we should tell it that the address that x is in is not really relevant anymore, right? So we could potentially put something new there. We're about to wipe it out. So we compile the expression first. Before we do anything with our state, because we could have an x on the right-hand side, we want to compile the expression before we modify our state, otherwise we potentially lose out on some optimizations. So this is now a result, and it's not mutable, and we can probably bring this in a little bit. We now need to extend instead of do this mutably, because that's silly. I don't know why I was using append everywhere instead of extend, but there you go. Not super knowledgeable about Rust either. We're all learning about Rust together here. It's been a shared journey, and I'm glad I've shared it with chat, because otherwise it would have been very, very painful. So it's really assign from stack to local. This is where the magic happens. I think this is in util. I think this is in CodeGen util. Assign from stack to local. So what we probably want to do is say maybe pub assign from register to local. Right, so say instead of, and then we can just call one of these helper functions depending on what the result is. I think it's good wrapping these up in helper functions. And this is going to be very, very simple. Now, obviously, this is going to wrestle with a few of the registers in our state. So this is going to have to modify the state as well. Maybe we need to pass the state in here because, you know, our state, for example, is going to say that we have something in particular in register B, but after this, we don't anymore. So this is the toTemporary problem again. This is the toTemporary problem. Instruction add, we get the base pointer. Is there a way to do this without using two registers? No. We need two registers because one has to, the address and the value have to be in separate registers. That would be nice if we could hack around that somehow, but that's okay. That's okay. So this is going to be the same pair of instructions, we just don't do a pop first, basically. Except we need to take the register as well. And this is just whatever random register we have kicking around, which is beautiful. And this also should not be the letter L, it should be an open bracket. Cool. Okay, so, but we do need to pass through a state to this. If res.destination expression, so if our destination, if our expression is in a register, then assign from register to local. We dump these into our outVec. We take the type. We take the offset of the local as a U8. We also need the register, which is going to be R. And we'll also pass through the state. We'll also pass through the state.clone. And this doesn't even, there's no error here. There's nothing that can go wrong here. Otherwise, we do it like this. And this is also going to take our state.clone. This isn't quite ideal though, because any changes aren't going to bubble back up. That's a bit of a problem. Actually, that's a really big problem with how I've done this before. We've threaded these states into a lot of places, but we're not really examining the contents of them. We're not really considering what comes back. Now, we can, because when we compile an expression, the expression result the expression res does give back a new state. So if we care about the changes, we have to look at what's in this result, basically. Here, for this kind of thing, it doesn't work so well, unless we pass a mutable reference to a state. Maybe. Or unless we modify the state up front, unless we say state. But then, now, this happens in a loop. So I guess we need a mutable variable called state, right? Where we shadow this argument, but now it can change. Now it's actually mutable. Now we're not afraid to change it. Because, for example, in here, we're going to say state equals state dot copy with temp, right? Make sure we have 2 temporary registers at least. What exactly does state hold since you missed the stream? State holds a list of registers that we're allowed to use for intermediate computations and their current state. So, for example, CodeGen expression. This needs to go in its own module, probably. A state, it's a hash map with registers and the state those registers are in. We only have 3, maybe 4 working registers. And one of these is always assigned to being a temporary, which, you know, has its problems. So it's a little bit jank. Right? Register C, we always need to be able to pull out and say, hey, this is used for intermediate computations. Now, what I'm doing here kind of implies to me that maybe we don't. Maybe we could just make this free for things, but if an operation needs to use it as a temporary, it can kind of make a new state that asserts that. And then afterwards, we probably need to be able to say something like state dot. And actually, this probably doesn't even need to be a copy. This can probably just you know, so make sure we have 2 temporary registers, and then maybe we pair this around everything that needs temporaries, right? Anything that was temporary is now no longer temporary. And there's no real reason to keep these intermediate values around, right? This is, and I guess actually it's kind of interesting to say that B is the base pointer. Like that's not awful, is it? So maybe the way I'm thinking about temporaries isn't quite right. Anyway, let's not go too far down that path, but I do need to be able to say, hey, I need temporary registers here. But the way temporaries work, they're kind of sticky. So if something's a temporary, it's not valid to use for anything. It's not. Well, I guess it is, but like it never actually holds state. You can use it. So probably it depends, I guess, on where it's being used. In this case, it can't. Because this is a statement, it can't, right? So we're in a statement, like line by line. The only place this can fail would be in the middle of a chain of expressions where you've got like binary operators combining them. In this instance, we can always kick whatever is in a register out. There's no intermediate computation in progress because this is the left-hand side of an assignment. So I need to be careful. You're absolutely right. This is a very dangerous game I'm playing. I think binary expressions will also need to assert this up front, right? There will need to be 2 temporary registers, which calls into question a lot of stuff. Why am I even doing this if I only have 3 registers? But I've already seen some decent improvement. So it's not like it's not going to be super optimized code, but it can actually be quite clever in a sense that it doesn't just abuse the stack for everything. If it needs to, it can. Yeah, sorry, yeah, Mr. Ed Makes. If you're like, what is going on here? This is because, oh, sorry, how long have I been writing compilers? This is my first compiler. I missed this comment. If you can't tell, this is my first compiler. I'm working this stuff out as I go. I'm making up APIs and doing this as it feels right. Let's make these take a mutable ref. This is for the Rust Simple V on my GitHub. Exactly. It all lives in the one repo. Maybe it would be worth kicking this out to its own repo at some point, but like it's a pretty hefty language, but I think monorepo is okay for this. It's pretty tied to the VM. It's pretty VM specific. This might feel unsound, but I know where I'm going here. So we're gonna take a state here. We're gonna take a mutable reference to a state, and I'm gonna do something really weird. So we'll say let value. Oh, except this only needs one temporary because. Oh, this is way better. Hold on. Okay, so this is it. It's happening. So we're gonna get a temporary from here, and then we're gonna get a temporary that's different. We need to get a second temporary. Let's maybe say get temp pair, right? Because get temp only knows to give back one temporary. We'll have this thing where we can say, hey, we want 2 temporary registers to work with. I don't think we ever need more than 2. So we'll say 2. Why'd they limit myself to 3 registers? I have 8 registers, but there are only 4 general purpose registers. One of them also, so the way my VM works, the program counter is a register, the stack pointer is a register, the base pointer is a register. I might be able to reclaim the base pointer for a general purpose register at some point, but basically it only supports 8 registers because it's a 16-bit ISA. That's just how I chose to do the bits. It's 3 bits. So I kind of have 4 general purpose registers, but because it's a 16-bit VM with 32-bit memory, one of those is a page register, and I'm gonna have to be smarter about how I do this, right? I'm gonna have to track more state. So the page register isn't really used for anything right now. It's pretty much just untouched. I'm hoping to have more registers to play with in the future, and I'm building this with that in mind, but even with 3, it can actually potentially juggle quite a bit of information. Reserve temporaries, this is a better name, you're correct. And then I probably want to be able to say, stop reserving 2 temporaries. Give it back. Let it just be a free register. But yeah, I think this is a sane function. This is a reasonable way to go. So we pop into the value register, and then we move the base pointer into the address register. We do this add into the address register, and then we write the value register. Cool. This is a lot more general, right? This feels a lot better. No longer hard coding to these specific registers. Stack pointer, base pointer, still hard coded. They're not general purpose. Cool. So, similar thing here, right? Except we're gonna set. Why is this indented wrong? We're gonna say we only want 1 temporary, right? Because we already have a register with the value in it. So that's good. So this only needs 1 temporary. This is much better. So we say let address register is state get temp. Cool. And this might be register B, it might be register C. We no longer care. We no longer know or care. Comma on line 81. Perfect. Beautiful. Thank you. For some reason, I'm DD'd instead of DT comma. Classic Vim error. Okay, that's good. Yeah, so we probably want to say... So 1 temporary is the default. Let's say reserve... And we'll say like state on... maybe we go back to just saying reserve 1 temporary. This feels a bit flimsy as well. Let's go with this to start with, because I can't think of anything better. But let's say anytime we reserve 2, we have to reset that state. And if we forget to reset it, that's okay. We're just going to end up doing a lot of stuff on the stack. We can survive that, but that's okay. So this is good. Now, the only other thing we probably want to do, is, well, I guess we write it to a, We write it to a thing. We want it, whatever the value register is, right? We just want to kind of say, hey, this now has a variable in it. And I guess we can do that here as well, except we don't have the name of the variable. So now we've got this data communication problem. Lowering to an SSAIR would make some of this stuff easier. Yeah. But also when I have so few registers, I don't know if you would get huge benefits from doing this, right? Like the LLVM thing. It would be weird trying to handle many registers. I don't know. If I had a 64 register machine, that would be a really fun optimization to try and do. So, can I communicate this back up? Because, and this is where we need to say, by the way, this is where we need to say if this thing was previously in a register. How do we tell? How do we communicate back? I guess this always ends up in a register, right? There's always a value register. So if we're assigning from register to local, then we know that this register, we can say state dot set literal set get variable register. We don't have a way of setting a variable register, so that's a bit of a problem. We want to say set variable. We want to take the name. We're going to take the register. Now we want to match whatever the state of the current state is. So we want to say self.registers dot get r. So if it's get reference to r, maybe. If it's a, let's copy and paste this block and just work from here. I think this is good. I think I probably want another type of register state though, right? And this would be really useful with this kind of assignment, a register state where it's the base pointer. And again, this wouldn't survive across function call boundaries, but if we've already got the base pointer in a register, don't put it in there again. If you want to use it as an intermediate value, great, override it. It's not the base pointer anymore. But if we could save doing that move, that might be useful. I don't know if it'd ever happen in practice, and this is why it would be good to be able to benchmark this stuff a bit. And maybe this is actually better for static analysis, right? Maybe that makes more sense in a static analysis pass. We can see we've just moved a value into the base pointer, and then we do it again, but that register isn't used in between, so we could just remove a move. Maybe that makes more sense. Maybe that's better. Okay, anyway, I don't want to get too sidetracked by further future optimization planning. So if this is a free register, then we want to override it with variable, and we say variable string. Cool. If it's a literal, we override it. We say, cool, this is now a variable. If it's a temporary, we can be like, yeah, sure, we tried to put it there. We're not going to remember it, but you can do that all you want. You can try. If it's a variable with a different name, we need to say if name equals other. If name is not equal to other, then we're replacing it. Yeah, sure. If we've somehow ended up in this state, just override it. Otherwise, do nothing. This variable is already in this register. We're already in the correct state. And if it's an intermediate, I guess this might be an attempted downgrade, right? We're attempting to... not downgrade's the wrong word. Because these things have a priority, right? A preference. So if we're trying to put... Downgrade's the wrong word. Downgrade's the wrong word. If we have a variable in a register, we're trying to just use it as like an intermediate thing for a literal. We probably don't want to do that. Maybe. Maybe we do. Maybe we do. Let's go with this for now. Let's go with this setup. We shouldn't end up in this state, but we'll see. We'll see what happens. There are going to be problems here. So set, let's say first, if let sum r is state get variable register. So if this variable is in a register, and it's the name, where is our name? Our name is here. If r is not equal to, so if it's in a different register, then we want to put state.set variable register. We want to put it in the new register, and it's ID 0. We want to put it into the new register. We did it like this. And we also want to say state.clear. Invalidate? Yeah, invalidate. We'll say state.invalidate current reg. So it's moved from one register to another, which is a little bit impractical, but it could happen. It could happen. So we've moved it. We've said, yep, this new register has this variable, and we're going to invalidate this one. There are lots of ways where this can go wrong once we start thinking about taking addresses of things. So we're going to have to have some fences where we just invalidate everything if you do certain things. I don't know how C compilers deal with this, right? If I take the address of a register, do I just lose the ability to reason about when it's in a register? Maybe. That would make sense. That would mean we need more in state. We would need to track what variables are allowed to go to like be in this state at all, right? Maybe we have, if we're ever taking the address of a variable, we just don't do this. But then like you could also modify it from the base pointer. You could just take the base pointer and do stuff. You could override, like you could start with the address of one variable and override the next variable, which should be undefined behavior, I think. Like maybe that breaks your program, maybe it doesn't. A C compiler is smart enough to know that it's not going to use the value in a register as an intermediate if you modify like base pointer plus 10 and override part of its value. Does it know? Is it smart enough? It probably is, right? You can do that statically, but I'm not going to. If you take the base pointer and break the contract of accessing variables by their name, that is undefined behavior. My favorite word in C. They don't do range checking at runtime, but at compile time, right? You should kind of be able, like if you take but you don't, because like the compiler knows the offsets of variables in a stack frame, right? The compiler does know that at some point. So it should be able to know if I take the address of register A and then I add 50 to it and modify it, the compiler should, in theory, in some cases, there are cases where you do that dynamically and the compiler knows nothing, but if they're all static offsets, the compiler should theoretically be able to know that you've touched variable B because you've added, like, it could calculate where in the stack frame you were. But that's really complicated, and I don't know if the right parts of the compiler know the right things at the right time to make those guarantees. So, okay, we're writing code, we've got functions that don't exist, but that's okay. We'll get warnings when we try and compile it. So now we have to do this thing, assign from stack to local. Now, we want this to tell us what register it ended up in. We want this to tell us something. So when we assign from stack to local, we're going to say this returns a register. And we're going to return the value register. So when we assign from stack to local, we'll say let reg equal this. And this block actually kind of probably wants to live, because we're just going to copy paste this several times in fact. So we probably need to find a way to make this not copy and paste. When you take the address of, yeah, the compiler has to assume a pointer could be to anywhere. But the address of a local is a little bit different, right? But I know what you mean. I know what you're saying. Once you take the address of something, I think you lose a lot of your ability to reason about the state that it's in general. So I assume that what I just described, like if I take the address of X, I can no longer be as strict about what I understand as the value of X at any given moment. I think that's fair, and I suspect that's how compilers kind of deal with that. So if you want to write really optimized code for this language, you don't take the address of variables unless you really have to, because the variables you've taken addresses about, I can't make the same promises. Basically, we're going to end up with a blacklist. I'm not going to do that right now, because I'm just going to say if you do silly stuff, that's on your head. This language is in development. But when I say it's done, there'll be like a blacklist somewhere in here that just disables optimizations essentially for that variable. So we get the register we used, right? When we assign it to a local, we have to put it into a register first. So when we do that, we end up here. Cool. Now this does take a mutable reference to the state. It doesn't currently take advantage of that, but that's okay. That is okay. What if we have an arg? Can arguments live on the stack? Yes, it's the same. It's really the same. It's very, very much the same kind of thing. This is no longer mutable. We're just going to take the result. This doesn't need to be on a new line anymore, I don't think. 97. I think Rust FMT wraps after 100 characters maybe, so that should be okay. Instead of state, we're going to do a mutable borrow. We're going to extend, so this no longer needs to be mutable, which is beautiful. Now, we'll say if res.destination is expression destination stack. If it's on the stack, then we assign from stack to arg. Otherwise, we're going to do the same thing of assign from, except this has to be backwards because we want to know which register it is. That's okay, I forgot. So if we have a destination, we'll have to write this function as well. We'll assign from register to arg. We're gonna take, oh no, hold on, what am I? This takes a clone of the state. My mistake. We take the index, we take the register, we're also gonna, this is where we take a mutable copy of, a mutable reference, sorry, of the state. And the same thing here. And then we do this as well. So this can probably be a helper function somewhere, right? This probably, let's maybe say current reg. Yeah, so let's make a function out of this. Let's call it move variable to register, or update variable register, which takes a register, an old register and a new register. Or maybe even a new register and a state. We'll state. That isn't quite what I wanted. Okay, so if the variable is already in a register, then we invalidate the current register, and we always say that this variable is in a new register. It also has a name, which is a stir slice. Cool. So we say name, new register. Perfect. We're going to write this a lot. Update variable register. So that's this. We say update variable register. We have a new register. We have a name, which is ID 0. We have a register, and we have a borrow of a state. It doesn't need to be mutable. Doesn't need to be mutable. We'll just borrow it. Just borrowing, just looking, just peeking. Oh no, wait, it does. It is mutable because we're mutating it. We're mutating it here. We do a set. So we do invalidate is mutable as well. What am I saying? What am I saying? It needs to be a mutable borrow of the state. Now this depends on this. So I don't think we can actually mutably borrow twice here, but we'll see. We might need to clone or something. We'll see. We'll see. We'll see if that's allowed. That might be illegal. And then we do the same thing here. We say update variable registers. This is certainly a borrow checker violation. Oops. We have the compiler's getting ready to yell at us. Okay, cool. So similar thing for arg here, and then we just update the variable register, right? That's kind of cool. And when we do this on the stack, we also, when we do this on the stack, we need these temporaries. When we do this, the stack needs the two temporaries because it needs to pop the value off of the stack into a register as well as the address. Here, the value's already in a register, we only need one. We only need one. Okay, that's good, that's good. So we're gonna see a lot of this pairing, and that's really silly, but we'll survive. So, register to arg. So same thing here, we need to reserve temporaries for this. Nice. I think that's okay. Sometimes we're gonna do more work, more meaningful work with more temporaries reserved. Here we're just kind of abusing the API. It's basically just saying clear one register, temporarily make it only fit for a temporary, but then change it back. Excellent. Super Cricket, hello, welcome. How's RuneScape? I see you've been on the Iron Man grind again. Ethernet and a new monitor. That's good news. Ethernet's always a good time. Man, my Wi-Fi is awful. Oh, sorry, I've got to keep dragging this over. Right now. No, maybe at the end of the stream I'll duel you on CPM 22. That might be a fun way to end. I am keen. I played some games with, who did I play? Was it Berto? It was probably Berto, right? He beat me really badly on CPM 22. It was fun. But yeah, I'm keen. CPMA is good. I played Deadlock, and now I'm thinking about pointing and clicking again. So this felt weirdly easy. I talked a lot, and I had to think a lot, but it felt weirdly easy to get here. Globals, we're never going to put globals, we're never going to remember where a global is. We're just not going to do it, because globals are just kind of special, right? Because a lot of this is going to be scoped to a function, we can kind of say, yeah, sure, put it in a register, that's fine. But it's harder to know if we've ever taken the address of a global, or maybe a global is just a special address, right? And maybe the stuff in that address isn't fixed, right? It's kind of like being volatile. I think we treat all globals as volatile, and volatile is maybe the key word. Maybe it's not a blacklist, maybe it's a list of things that are volatile, and once you take something's address, it kind of is volatile in that same way. Cool, so we do need to do this change as well though. We take the result of compiling an expression, and we append, we extend the instructions, register, so we pop into register C. So now what we do instead is if it went into a register, so if this value is already in a register, then we still do this check. This should probably come first, right? We can blow up early. I think I've kind of already done this, but we'll get there. Right value, we load it into, yes, that's right. So this actually uses extra registers. So if this is already in a register, we need to get a temporary register and the page register. So let's say let adder equal. So if this is in a register, this is the same kind of thing, right? The same kind of problem we had up here, where we need two registers to kind of juggle. This already has a register, so that's okay. So we get the state we get the temporary register. We load an address to here. So the address register, let's call it reg, and then the page register, which at some point we'll ask the state for. Maybe we can do that now, maybe. But for now, let's just hard code it still to register M. It makes us a bit less versatile, but let's just hard code it for now, even though we're actually crashing if it's too big. We're passing the right kind of information around so we don't have to rejuggle all of this stuff later. Okay, that's the goal. That's the goal. And then we write the value like this. Except now, instead of this, we have a value register and we have an address register. Cool. Otherwise, it's on the stack, in which case we need to do this pop and then this write. Except we need to do the same kind of thing we were doing in our other functions, where we're going to say state.reserve. Did I call it reserve temporaries? We need two temporaries. We're going to say let value reg and address reg state. There goes my light. It was nice while it lasted. Get temp pair. So we want two temporaries. And then this is the value register. This is the address register. And then we do it like this. Value reg, adder reg. Beautiful. Beautiful. Okay, that sounds good. That sounds good. I think that is going to work well. I think this is nice. I think this is nice. I don't think we need this anymore, right? Because I think load address 2 kind of handles this. Yeah, load address 2 deals with this. Okay, so we're going to get rid of this. We don't need this anymore. We can handle big addresses. We can handle globals. Globals can live anywhere we want. Anywhere we like. That's cool. That's cool. All right, so maybe I shouldn't do this either. Nice. So that looks like variable assignment is going to do some cool stuff. Now, let's make B and look at all these errors, because there's a lot of them. There's a lot of them. Update variable register. I guess that's just because I forgot a semicolon. Have I done that other places? Probably. Yep. Anywhere I copied and pasted, right? I'm gonna assign. I think that was actually a different error. Expected a thing. Assign from stack to local. Anonymous parameters are removed. Yep, that's because I didn't give this a name. That's okay. That's okay. That's also a copy-paste error. What else? What else have we got? Can't find ID in this scope. That's because it's called name. That makes sense. State. Can't find state in this scope. That also makes sense because we're going to use crate, compile, expression, crate codegen, compile, codegen expression. Gosh, test stop. Wow, okay, so we've got more warnings and stuff. This is good, this is good. Assign from register to local, expected a type, found a register. That's okay. Let's get rid of test stop, I guess. Oh, actually no, this is gonna come back. I just commented it all out. That's okay. So, we expected assign from register to local. Let's look at util. Assign from register to local. The register should come before the type. That's okay, that's easy, in fact. What else have we got? Reserve temporaries doesn't exist. Let's do that. Let's do that. Let's say reserve temporaries. I guess we'll do a U32, maybe. I don't know. Numbers are hard. And this isn't going to return anything. Maybe this should return like an error or something. I think we're just going to panic if it fails. Because this is like the worst thing that can happen. This is like unredeemable error. You know, this is deep my error that you should never have to deal with. Okay, maybe panicking's a bad user experience. This whole project is a bad user experience. It's just me experimenting. Okay, so what does reserving temporaries mean? Let's get the current count. Let's say temp count equals. Now let's do this the clever way. Self.registers.values. Hold on, I need to pull up my docs. Let's get the docs. Okay, so API documentation. What are the different hash map iterators? Values, iterator visiting all values in arbitrary order. Nice. Okay, so values, we want to map any temporary. So if, let's say, lambda v, let's say match v, if it's a register state temporary, this is going to be 1, everything else is going to be 0, right? Then we're going to sum it, and I think that's everything we do. So we do this in a very functional way, right? We count the number of temporaries. Every temporary is 1, everything else is 0. If temp count equals n, we're done. We don't do anything. So I guess that's kind of the default case. So if we want more, if we have too many temporaries, then we want to maybe 4 I in 0 to temp count minus n. So if we want 1 and we have 2, we want the difference to that, which is 1. So we go through these and we do something. We let r equals self get temp, right? So get a temporary register, and then let's make this so this is going to be a pub function, but we'll make untemp, or maybe set temp. Right, so set temp is gonna not be public. And this has to be mutable as well. This is a mutable borrow. Cool, so self, we're gonna take a register, and we're gonna take a state, which is gonna be a bool, and we'll say if state self.registers, this should be, hold on. This should be registers, insert so if we're setting it, set it to a temporary, otherwise, and actually, hold on, we can make this even simpler. We can use an if expression here. We can say if state, then this, if state, then it's a temporary, else register state free. If it's not a temporary, if we're demoting it for a temporary to something else, it just becomes a free variable that could be used for anything. Cool. I think that's good. It's kind of like saying whatever we knew we had in here before, we've forgotten. And then else if temp count less than n, whatever the other difference is, we want to set it to true. Except we want to get a free. Now, if we're out of free variables, free registers, we want to find anything that is not a temp. So if we're out of free registers, I don't even know. Get something that's not a temporary. Get anything else and just obliterate it. Invalidate. If we only want to do this if it's not a temporary. So if it's a regis do nothing. Yeah, sorry. So there's like a couple of little things in this API that are a bit tricky and annoying to deal with. These also have different return types, I guess. That's annoying too. I think I have to do that. Okay, anyway, sorry, this is getting a bit messy now. We just need to be careful we'd never change a temporary into anything else now that we're doing this weird Django stuff. So if we're out of free variables, for now I'm just gonna to do, just so I can keep moving forward, because this is a bit annoying to wrangle. I need maybe a different way of doing this. So you're not allowed to call this yourself. You have to defer to the wisdom of reserved temporaries. You can't change. You as the caller of as the handler of this state can never actually manually set or unset a specific register to being free or not. You have to use this API. So what happens now if I build this? That function's probably going to yell at me. Assign from register to arg. Assign from stack to arg. I didn't make assign from register to arg. Also, I didn't make it actually use the I didn't make it use the registers that I passed in. So let's sorry, this is in block. Assign from stack to arg. It now takes a state. And I guess this should be internal to this function, right? Because it's a mutable ref. Let's not do that right now. Let's let that cook for a second longer. Stack, so we want to do what I'm doing up here. This is going to look pretty much the same. Assign from stack to local. We want to grab this. Assign from stack to arg. And we just do it the same way. Value, register, address register, and then we store the value register to the address register. Beautiful. And this is on the 0 page, which is a little bit hard-coded, but that's okay. That's okay. We just assume that that our stack is on the 0 page. That's a fine assumption to make. That is a fine assumption to make. Stack to arg. So this, I guess I'm making this one register to arg, and this is the same kind of thing, but assign from register to stack to local register to arg, which takes a register and it takes a state. Cool. So here we just skip this step. We say let add reg is state.getTemp. And then we use this register, we use the address register, and it's on the 0 page, because that's where our stack always lives. By necessity. Assign from stack to arg now also needs to return the value register, because we use that in the resulting computation. Okay, excellent, excellent. That's a bit nicer, that's a bit nicer. Register, expression destination. Okay, that's almost certainly a typo. What is my typo? No variant selected. You know what, I'm going to get rid of test op as well, because this warning being at the top every single time is just too annoying. It's just too annoying. No variant, reg ist. I really made a dog's breakfast of spelling that. That was really not great. GetTemp is a private method. That's not right. GetTemp should be a public method. Everyone should be able to call getTemp. Invalidate should be public. Maybe at least within the crate. GetFree should be pub within the crate. GetTemp should be pub within the crate. SetLiteral should be pub within the crate. They're all going to be pub within the crate, except for the really janky internal stuff. Oh, I was like, how did this work before? But the things calling this are currently in this same file, which probably won't stay that way, but that's okay. Reserve temporaries is pub within the crate. Cool. Okay, that's good. That's good. The whole API, except for the stuff I don't want people to use, is now crate public. Beautiful. Address register found. Optional register. GetTemp. Dot unwrap. GetTemp returns for some reason an option. That's okay, I guess. We're just going to unwrap everywhere. I'm going to run to the bathroom for a second, so I will be back shortly. I think I need a little breather. Back in. Ooh. Back to work. We were dealing with this massive mountain of compiler errors, which is fun. Because when I get a temporary register, so get temp pair we have to write. This does not exist yet. So let's do this. And yeah, let's make it actually return an option, because then we can unwrap it, and that's just better. Let's bake the failure into the type. That way we can just unwrap and blow up now, but the API will be consistent so that if we want to handle it properly in the future. Cool. So I have to do this a little differently now, I guess. I want to maybe for reg state in, I guess I do this the same way. Let's say let mut first, or maybe I say, oops, API pair. That had all the same letters as pair, and for some reason the word API came out. I think I said API as I typed it. Okay, so let's start this by saying let temp equal so let's try and get a first register first. If it's none, then the whole thing is none. If we can get one. Now we're going to look through every other register, but if it's a temporary and reg is not equal to first. So if it's a second register, then we're going to return first and the second register. Excellent. And this needs a semicolon, I think. Feels like it needs a semicolon. Anyway, we'll find out. Now we need to unwrap here. Register get invalid. Oh, that's okay, because expected register found register. We just need to borrow. That's fine. Mismatched type, temporary expected. If it's a sum, that is the missing step. Cool. Register equals register. We need to dereference this register to compare them. That's good. What's next? What's next? This is going to have the same thing. Wait, hold on. No, that was different. That was different. We'll get back there in a... Let me do it now, otherwise I'm going to forget. We're in expression, pair. This needs an extra set of brackets because otherwise it's just like, otherwise it just doesn't know what's going on. Okay, mismatch types. Oh yeah, so this needs to be a sum. This needs to be a sum. We just need to wrap them in a sum. But if we get something that isn't a sum, then that's probably like a panic because we're handling register. Well, actually, but this returns an error anyway, so does it? I mean, it doesn't, but it maybe should return a result. A result that says register state error. So it's unit register state error. And we do have an error for this. We do have an error for this. So this should maybe be an error register state error invalid register R. And we already have that. That already exists. Beautiful. So this is like we're trying to set a register that's like, we're trying to set the stack pointer or the base pointer or something. That's what encodes this. Okay, beautiful, beautiful. If name other, name to string. Expected a result, found unit type. Why? Oh, that's okay. That's what we need to do here. What's next? Set temp, mismatch types. Set temp because R is... What's R? Where did R is a get temp. We want to... we'll just unwrap for now. We'll just unwrap for now. Get temp, set temp. Get free, I think we also want to unwrap. Beautiful, beautiful. Expected a register, found an option. Oh wait, no, sorry, that one we don't unwrap. Of course, of course. Okay, temp count, type annotation needed. That makes sense because it doesn't know what it's summing into. We'll make this a U32 as well so that we're consistent. If I is unused. Yeah, this can just be an underscore. I really struggle to type the word register. Register. Typing is really hard, man. Expected a unit because of the return type. That just needs a little semicolon. That's okay. RT is unused. That doesn't feel right. What's going on here? Compile expression. Binopmol. RT. Yes. Oh, because we have two temps. Cool. This is kind of dealt with, but let's just put a... let's put an underscore there. I think that makes more sense. Okay, cool. Out is unused. That's a bit of a... That's fine. That is actually fine. So, can I compile a program? Not quite. Mismatch types, expect. Okay, so there's still a few things, so we're gonna... These are just warnings. Let's just do this thing to keep going, because we're maybe not even gonna get to this today. RHS. So hold on, so that one... What's it saying I don't need? LHS type, sorry, that's only one thing that's unused. Okay, RHS type as well. What is this saying? Get temp pair, this needs to be unwrapped. Arg register, mismatch type, add arg register. Arg register is an option, it also needs to be unwrapped. That's fine, this is going to be the same thing again. Arg register, same thing again. This also needs to be unwrapped. Cool, and then this looks okay. Load address 2, that's fun, because that already takes a register, which is great. Alright, we're getting close. That whole thing built. Incredible. What is the most important thing we're missing here? Binop compare is never used, that's fine. Set register has a result that is never used. We'll just unwrap it. Nice, that's really good. Okay, so what happens if I build this right now? It gives us an error, that's okay. What is the error? Undefined variable x. That's unexpected. That's very unexpected. Variable undefined. Because we need to say let. Okay, so what does the code look like if I compile this and put it into my little viewer? Do we get a real binary? Does it do real stuff? What does the code look like? So I guess if we just tick through it, do we end up with 17 in the A register at the end? No, we do not. That's okay, that's okay. Let's tick through and see what goes wrong. So we load these two numbers, we add them together, this is good, we get 17. We still do this pop into C. I don't know where this comes from. Oh, no, this comes from... Okay, hold on. Whoa. This comes from the fact that declare is using a different code path. So what we need to do is say this, right? If we do this. Unknown type. Let int x. So we declare x, and then we assign to x. Cool. So now it's going to actually use our code. It would be nice to just reuse all that code where possible, right? To make it simpler, because now we don't have this extra pop. I think this might be it. So I'm just going to tick through this and see if we end up with 17 in the A register. That would be really cool at the end. And we do. Okay, so that's exciting. So we can see the code's a little bit different. There's a little bit less stack stuff. So this binary operation chain is actually able to be much, much more efficient, which is great. The really good optimization would be to say, hey, we have X in a register, but then we just return it. So we don't actually need to write it to the stack frame. But that is another level of static analysis that I'm not getting to yet. Just for now, not pushing and popping things unnecessarily. So what happens, right? So let's reset and tick through again. So this is the start of our function. We add space on the stack frame for the variable, which again, we could completely skip if we determined that we didn't need it. Also, Stretch Bioinfo, thank you very much for the follow. Welcome. We are compiling. We are optimizing. We are a lean, mean coding machine. Okay, so we add 5 and 2 together into the A register. We add 7 to it to get 14. We add 3 to get 17. What is this? We load the base pointer into C. Before that always happened in B. Now it goes into C because it just is able to. We add 0 to it. We should skip this, but we don't. Because this is the first thing in the stack frame, and we store it there. So now 17, the variable x, its value has been stored. Now we're going to load the base pointer into C again. So this is actually a case where we could, if we were a bit smarter, work out that we already had this address in C, right? At the very least, skip this. But I guess if we add an offset to it, anyway. Maybe what we need there, right? Maybe what would, and I'm not going to do this right now, but just to kind of, rather than me just talking about it, let's look at a register. Maybe we could have a base, or maybe a frame offset, right? So if we do this, we would say that this register has the frame offset 0. If we add 5, or if we add 6, we would say we had the frame offset 6. It's always an even number. That would be really cool. That would be really useful. Very practical. So this is something that would be a nice to have. That could save a little bit of duplicate work, especially for this case where we save it and then instantly load it and use it somewhere again. So this still goes through the stack. Okay, so how do we avoid this? How do we avoid putting this through the stack? Because ultimately it ends up in a register again. So this is another expression optimization that we're maybe not going to do right now. So this is still a little bit inefficient, but that's okay. We load it into the C register, we push it onto the stack, we pop it out into the A register, because we kind of have to. We have to get it into the A register to return it. So it's still a little inefficient, but this is much, much better than what was happening before. Okay, this is so much smarter. Just for comparison, right? So this is 58 instructions. Let me do something really silly that's going to disable all of these optimizations. Let's say What if I just say they're all temporary? Right, what if I do this? And then I load this binary, which is going to go through the stack a lot more, and it has 10 extra instructions of just stack juggling to make this work, right? So, and you can see, right, instead of just doing all this nice register stuff, it all goes through the stack to do the summation. So that's kind of cool. It's fun that I can turn it on and off. And, you know, eventually I'll have some kind of like flag in the compiler to toggle this optimization. Not because you would ever use it, but because turning it off is an interesting comparison and an interesting debugging tool. Cool. So that's really good. That's really good. So what was my goal again? Variable assign considers registers. It almost does, but it would be nice if this worked for declaration as well. Let me commit this first, because holy crap. Add lang variable assign have to cargo format first. Excellent. Does Clippy have anything to say before I go too far into this? I'm sure it does. If chain can be rewritten with match. Oh, that's interesting, isn't it? That's really interesting. I guess you could also rewrite this just differently in general. You could say let diff equal if temp count greater than n, temp count minus n, else. Right, so we could handle this diff in a different way, and then we could say for, like, do this n times. Except in this case, the behavior is a little bit different. Okay, we can't quite do this. So it wants us to match this. It wants us to say match temp. What is it? How does it want us to rewrite this? Like what? CMP and match. I don't know if I like that necessarily. Replace closure with this thing. That one I can do. 291. Expression 291. We can just say register state. That's fun. Return reg value. Unneeded return. That is also fun. Yep. Value reg. I don't really know what it wants here. Clippy. So there's a way to like apply these Clippy changes, right? Automatically apply. Clippy fix. Let's try it. Let's try it. Okay, well, let's add lang source. What changed it? Yeah, so let's add lang source. We'll just add that to the previous commit. Let's try Clippy fix. Dirty. Sure. There we go. Did anything change? We'll find out. What the hell? Why did it change? I didn't realize it was going to change all this stuff. What's happening here? This is nice, but it's not what I want right now. Weird. Okay. Well, we can think about that more later. What do we have? Binop compare. So binop compare is unused. That's fine. That's fine. We'll keep the weird chain. We'll keep the weird chain thing because I think that actually looks clearer than whatever else it's suggesting. Even though I don't totally know what it's suggesting, I think my way is better because I'm very, very confident like that. So what was I saying? I want to make declare. I want to make variable declaration work better. So this is in CodeGen block declare. And this code path where we have some expression. So why is this so different? Why? Oh, because we know it's a local here. So this is like only having this branch, which is fine, which is actually really good. So let's copy and paste this. Let's copy and paste this, because this is what we're doing here. So when we declare a variable and we have a thing, define local. So after we define a local, we compile an expression, we append it, and then we do this check. We don't do this stack stuff, that's irrelevant now. I need to go in, I think, 4 levels here. Nope, 3 levels. Beautiful. So yeah, so then we have this weird push pop stuff. That is not what we want. Write value. That's fine. So that happens in... And actually, we should have been using assign from stack to local there. That's basically what we were doing, right? I think. Yeah, we've written this out. We have a helper function that does this for us now. Cool. So instead of this, we now say we get the result, we extend to get rid of this weird mutable thing. If the destination is a register, we do this stuff. And I think all my variables are named similarly enough. Not quite. This is var type or expression type. No, it's the variable type. We assign based on the variable type. The variable type is what matters. Cool, so this is going to be the variable type. ID, cool. So if I build this now, does this happy or is it going to yell at me? Offset not found in the scope. Local offset, it just has a different name, that's okay. Excellent, okay, so now if I find where this was, and I should be able to build, that's not what I wanted. What is this? That's documentation. Okay, so if I go into my test code, I should be able to now just say let x like this, and it shouldn't do the stack stuff, which would be great. Would love that, right? All the extra optimizations I can get would be beautiful. Add this one to 0. Yeah, so this is good. So this no longer pushes it through the stack. And if I just tick through here, it generates the same code it did before. 58 instructions, right? We're going to get to the end, and A has 17 in it. So that's really cool. That's really, really good news. I like that a lot. Excellent. Excellent. I might have to leave it there. That has been a monster stream, but I think we have achieved some goals. I need to stop drawing by accident. That was too much of my face. So we did this, and we did that. We didn't really add a toggle for it, but we did kind of examine it. And variable assignment now considers registers. There's a lot of little things to do, but I think what's really cool about this is now that I've done some of the heavy lifting, the actual code looks very simple, and it's able to quite cleverly use some of these registers for things. I still need to keep in mind that right now, none of the state gets reset between function calls, so that is probably the big thing to do next time, is think about function calls and how this is going to break, and just make sure that every type of statement is using the new API. Even if they're still doing things over the stack, as long as they use the new API, that'll be okay. Because if I make tests right now, I think some of these tests are going to break. Yeah. So like array, and this makes sense, right? Most of the tests are pretty simple, they just use variables. But once we're using things that rely on arrays, for example, the array expression might get Thank you, Bobius. The array expression might get compiled into a register, but it tries to get it from the stack. So it's just going to get the totally wrong index, and the address is going to be off. So anyway, that has been fun. It's feeling productive. It feels like we're getting somewhere. Even though I don't know what we're doing, it feels like we're getting somewhere, which is good. Thank you very much, everyone who has tuned in. Let's find a fun channel to go on and raid from here. Stretch Bioinfo, cool project. Thank you so much. Thanks for stopping by. Thanks for following. I hope you enjoyed. You know, you're always welcome to shout out with any guidance, advice, cool thoughts you have. And if anyone has suggestions for anyone fun to raid following this, please shout them out. Because we are gonna... Oh, I said I was gonna play cricket on CPM 22, didn't I? Cricket, do you want a duel? Do you want to play Quake before I finish? Otherwise I'm gonna find... Yeah, I'll fight you on stream. Let's do it. Let's do it. You're on. This window manager doesn't have the best refresh rate. Hold on, I need to get my mouse pad. Okay. I have a good artisan mouse pad, but I only bring it out when I game. I need to plug my mouse in. I got a few things to do.